Hi, good morning or good afternoon, whenever you're listening to this video or looking at this video, rather. Right, today I'm just going to take you through the paces of conducting a one-way repeated measures ANOVA using SPSS. Just to reiterate, to remind you, the whole purpose of conducting one-way repeated measures ANOVA is where you want to compare three or more group means. It could really be used in two major instances. Firstly, you may have a participant measured multiple times to see changes based on some intervention, maybe some drug, or as in this instance, in the example that I'm going to present now, you have where a participant is subject to more than two trials, and the response in each of these conditions is compared. So for example, if we look at this data set, we have 20 participants, some male, some female, and we are measuring each participant's task performance in a particular task based on certain environmental conditions. These here refer to the level of noise in the environment. So for example, if I look at participant number 8, in where there was no noise, his task performance, I'm not sure what the unit was used, was 44. In medium noise, it went up to 66, and in high, it's 51. So really and truly, perhaps the research question could be, are there differences in the performance of workers based on the level of noise they experience in the environment, or something of that sort? So let's get started. We go to Analyze, General Linear Model, and Repeated Measures. Yes. So you see this little window come up. You'll have the within subject factor name. Probably we can just put noise. So we measure this noise factor, and we have 4 different levels of noise. So we type in 4 here, click on add. Right, the independent variable really would be the, I'm sorry, this is actually dependent variable, which is the task performance, which is the measurement variable here. So we can just probably put task performance. On add. Right. So first, it's set up already. Next, we need to click on define. Right. We wanna enter now these within subject variables, the different noise levels, and we want to do them in the order in which they are presented. It could be order of time. In this case, is some ordinal level. So we want to do it in that order. So there are 2 ways we can do it. We can do each individually in that order, or we can enter all at the same time. I'll choose the latter. So you click on none, hold on the shift key on your keyboard, click on high, and the arrow here. There we go. We're not using any between subject factors. We could use gender here, which we'll do in a subsequent analysis. But for now, let's just go through this to answer the research question which I presented earlier. Are there differences in person's work performance based on the level of noise which they have in the environment? Next, we don't really need to click on model because we don't have any within subject factors and so on. So let's click continue. Perhaps you can click on plots, and we just look at the graphical illustrations of the comparison of the mean work task performance at the different noise level. Put that on horizontal axis, click on add, continue. Again, we wouldn't have any post hoc tests because we don't have any between subject factors. Just to give you an idea what it looked like. So if you have a between subject factor with 3 or more, we can click on that one. So let's click continue. All right, so let's click on options. Right, here we can, let's suppose we end up with a significant difference in the task performance based on noise level. We want to identify where this difference lies or where the differences exist. So we can actively do a post hoc test here. So noise, display means for, and we have compare mean effects. Let's choose the Bonferroni. Okay. We click on descriptive statistics next. Estimates of effect size. We don't really need the homogeneity test. I suspect that you're not going to get much from the residual plot to check for independence. Let's click it regardless. Continue. Okay. Right. So we know how sensitive ANOVAs are to outliers. So we probably would want to have a look at the residuals, and we can actually test for normality within the dependent variables as well. And we can look at check and see whether there are any outliers which may affect the results. So click on save, standardize, Cook's distance, leverage values, continue. And we're ready to go. So let's click on OK. So what do we have here? Here we go. Right. So here's my output. Right. So as I said before, you're familiar with this one. This is the descriptive stats, and we can see, for example, that at the medium level, the task performance was highest. It was lowest in the none. And so if you look at the mean plot, probably at the bottom here, it should be here. Yeah, here it is. So at the various noise level, the mean task performance went up from 40 odd to 60 something, and then it dropped back down to 40 again, 40 something. Right, so that's a descriptive. So we recall that when you're reporting on these stats, it's good to report on the number, mean, standard deviation. Just quote probably the highest and the lowest. All right. We wouldn't consider the multivariate test just yet. This is a repeated measures ANOVA. When we're doing MANOVA, we'll come to this one. So let's examine this assumption first, which is really the major additional assumption which we'll have to consider when we're doing repeated measures ANOVA. In the previous video, I explained what this is. So just to go over it, it's really the variances. We want the variances of the differences between all combinations of selected groups to be equal. So for example, just to go over it very quickly here. All right, there's the result. We see the residuals come up already. So if we calculate differences here for each participant, and then we get so between none and low, between none and medium, we'll get differences. Between none and high, so it's 4. We have four groups here, so we'll get 4, 3, 2. That's 6, right? Six different sets of differences. We want these calculated values, the variances of these, to be roughly equal. So we use the test for sphericity, the Mauchly's test for sphericity, to determine that. Okay, so it looks all good. Remember, we're looking at the p-value. These are corrections if the epsilon values, if the Mauchly's test proves to be insignificant. So the differences are not, the differences of the variances assumption is violated. Here we see the p-value is greater than 0.05. So we fail to reject the null hypothesis that they are equal. So we make the assumption, we say the assumption of equality of differences of variances is satisfied. So here's our major test result. Right, so we can just look at the first row in this because the assumption is satisfied. We have the sphericity assumed, right? 3 degrees of freedom. So when we're reporting on this as well, we report the F statistic and the p-value. So the p-value in this case, it's less than 0.05. So we can conclude that based on the evidence, the differences in task performances based on the noise level in the environment are indeed significant, right? So we quote that partial eta squared is probably analogous to R squared, tells you the proportion of variance explained by this variable, right? This independent variable. So we can look at the post hoc test, which gives us a pairwise comparison, where we are able to see a little more clearly where the differences, the significant differences exist. So when we look at this one, we see 1 and 2. There is a significant difference between the performance in 1 and 2. 1 and 3 as well, significant difference. However, 1 and 4, and we did notice that it came back down, the task performance came back. This difference wasn't actually significant. We can see 2 and 3 as well. It's a significant difference. Not significant between 2 and 4. Let's look at 3 and 4. 3 and 4, significant differences. So here, we're able to actually identify where the significant differences exist. Again, as I suspected, the residual process, they don't tell you much. Probably we can say, okay, so it will be for each of the 4 different noise levels. So you see, we could probably just say it look like randomly distributed. All right. We need now to look at our residuals. We want to look and see, determine firstly if they're potential outliers. And here, this one comes to, I see that as standard residual of negative 3.38, which is pretty large. Anything more than 2.53 or negative, either way, absolute values, we consider it, we need to have a closer look at them. So for the group, the second level, which was the low level, we probably would want to run the analysis without this. Again, we are challenged with the fact that we don't have many observations, so we don't delete. We just compare and see if there are any significant changes in the results, right? We also see negative 3.38 for 2. We have a relatively higher Cook's distance. So again, this is a potential influential observation. All right, so I think that's about it for this one-way repeated measures ANOVA. Next up, I will look at a factorial repeated measures ANOVA. Okay, until then, hope you enjoyed this. All right.